So let's derive Stokes' law. See, when we have an object falling through a fluid, what kind of factors comes into mind? Right? One is the stickiness. Of course, we have buoyancy. Other than that, you have the whole flow that you guys remember. I hope so. So the stickiness comes into picture, right? The radius of this is always a sphere, okay guys? This formula is only for spheres. So the radius comes into picture and velocity will come into picture. Do you guys agree? So basically, my force will be related to your stickiness, radius. I'll use small letter only. Yeah, I'll use small letter. And velocity. So this is the funda. Okay, guys. So first thing first, my LHS. So yeah. So I'm going to use. So with this, you guys should be able to tell. Yes. Dimension analysis to figure out the formula. Okay. So we have the LHS. So we have the dimension of force will be equal to m1 L1 T minus 2. So all of this should be natural to you guys, as in you should be able to recall this. If not, derive it. Okay, guys. Dimension, you guys derive it. This I kind of remember now because I have used it a few times. If not, I am not very familiar with it. Then we have the radius. So this is clearly just L. And we have velocity. And this also is quite simple. Okay. Now, if I substitute all of this in, say, 1. Okay. What do we have? A, B, C, right? Those are substituting in 1. So on the LHS, what we have is MLT minus 2. This is equal to ML to the power of A, B, and C. Now, what do we have? We have, let me combine all the M's together. MA, L minus A plus B plus C, and T minus A minus A. Is that right, guys? Okay, looks right. Now, we need to do what? Compare. Comparing the powers. So you will end up with A clearly is equal to A is equal to 1. Okay, and then minus A plus B minus C is equal to 1. So basically B plus C is equal to 2. How did I do that? As A is equal to 1, I substituted that and I got this. And then when we compare the T value, minus A minus C is equal to minus 2. So C will be equal to what? C will be equal to, this is 1, right? So that will be minus 1, so 1. And therefore, B is equal to 1. Okay, so we have, finally, on substituting, we have force will be proportional to your viscosity, coefficient of viscosity, your radius and velocity to the power of 1. And on through experiment, we'll be able to figure out that it is 6 pi times of the proportionality constant turns out to be this. Okay, so that would be your small derivation. I forgot to show you guys the set of conditions that you need to write your derivation should start from this actually. Okay, I have shown this in the last video, but yeah, you need to start with this and then move on to talking about this actual derivation.